I'm Dr. Kennan Crane. I am a research structural engineer in the Geotechnical and Structures Laboratory, and I am the team lead for the structural analysis and experimentation team that runs the structural strong floor where we're standing right now. So the strong floor is a facility where we can actually test large-scale structures with significantly large loads, either one time or over a period of time. We then use these large hydraulic rams to apply different loads to different structures. We can apply those loads up, down, sideways, and we can apply up to 1 million pounds. For some tests, we'll actually run that in what we call a monotonic load, which means we just push on something slowly until it breaks to get kind of its ultimate capacity. Or for some tests, we'll actually do what we call fatigue loading. And what that is, we'll take some load that the structure sees regularly and we'll apply that load over and over again until the structure finally fails. One of the simplest way to conceptualize this is when you were a kid, you took a paper clip and bent it back and forth until it broke. Any one of those bends didn't break the paper clip, but the summation of the damage during all of those bends eventually broke the paper clip. At a much simpler level, that's exactly what's happening here. Testing them in the structures lab provides many benefits. One of them is you don't have to have people driving over the bridge for hundreds or thousands or hundreds of thousands of passes with a large vehicle. There are all kinds of safety issues that come into play with that. Certainly driver fatigue. Also, when the bridge finally breaks, you run the risk of dropping whatever vehicle and personnel into the water, which is obviously very dangerous. Here in a controlled environment, we can apply the same loading types that you could apply in the real world in a matter of weeks or months that might take years in the real world to apply with vehicles. I love working out on the strong floor. I love working on large structures, seeing how things behave in the real world. So I always describe this, and of course I'm an engineer, I'm a little bit of a geek. I describe the sound that these structures make when we're fatigue testing them. It's like a breathing dragon, something straight out of a fantasy novel. And it's so impressive because there's no other sound like it. And then the other sound that not everyone gets to hear is when it finally reaches that failure point and something breaks. The entire structure will shake and the ground that we're standing on will shake. If that happens during working hours, we normally have people coming out of their offices to figure out what in the world happened. I think that it's important to understand from a safety perspective. It's also important to understand from kind of a pushing the envelope perspective, understanding how can we get the most out of the systems we have while still ensuring the safety of those who are using those systems. And that's important across the entire gamut of the work that the Corps of Engineers does, anything from military operations all the way to kind of traditional civil works operations. And this allows us to ensure that we maintain safety, but also get the most from the structures and the dollars that we have.